All right, this is a video just to make sure my students got answers to the periodic table trends activity that we were doing in class. If you look at your data, you should notice the following pattern. The first one we're going to look at is atomic radius. So as you go down a group, atomic radius is going to increase. And why is that? As you go down a group, you're increasing the energy levels that you're at. So this is 1s, this is 2s, and this is 3s. So going down a group, atomic radius increases because you're adding energy levels. And remember, the atomic radius is the distance from the nucleus to the outermost electrons. Now going across the group, or across the period rather, you should notice that the data shows a decrease in atomic radius. And why is that? It's because there is an increasing atomic number as you go across. Lithium is 3, beryllium is 4, all the way across to 10. And what that means is the nuclear charge is increasing. And because the nuclear charge is increasing, you're increasing the pull for the electrons that are in the same energy level. So this is energy level 2. Okay, and because we're not increasing energy levels and the nuclear charge is increasing, the size of the atom gets smaller because the nucleus pulls the electrons in tighter to the nucleus. So that's why we see the trend on atomic radius. Now you should notice when you look at the data for the other three trends, ionization energy, electron affinity, and electronegativity, that they all have the same pattern to them. As you go down a group, all three of them should be decreasing in their amount. And as you go across a period, you should see that they all increase in their amount. Okay, now why would this be so? Well, all three of them depend on the atomic radius. As you go down a group, atomic radius increases. And because it increases, ionization energy decreases, electron affinity decreases, and so does electronegativity. As you go across the period in the second row, okay, you should notice that they all decrease. Now there could be some exceptions here and there, or rather they all increase. There are some exceptions, but you don't worry about the exceptions. The general trend is as you go across a period, all three of those energies increase in their value. And why is this so? Well, it's all based on atomic radius again. As you're going across the period, the atomic radius is getting smaller, it's decreasing. Thus, the energies are all increasing. Ionization energy increases, so does electron affinity, and so does electronegativity. Why? Because the smaller atom has a greater attraction for electrons. Okay, and again, as you go down a group, the atomic radius gets larger, and therefore there's a less attraction, okay, for electrons, and therefore all of those energies actually decrease. Now what about reactivity? Well, it turns out the metals are more reactive as you go down a group and closer to the left. And why is that so? Well, metals want to give up electrons, so ionization energy, electron affinities, and electronegativities need to be small. So your fastest reacting metal is actually going to be at the bottom of the periodic table. Opposite for nonmetals. Nonmetals want to be farthest to the right and up. Okay, they want to be the smallest. Why? Because nonmetals are trying to receive electrons, thus a greater attraction for electrons means your fastest reacting nonmetal is going to be on the right side. Okay, so that's our periodic trends, all giving us answers to our worksheet that we had, and I will be doing some more demonstrations in class.